Okay, so I'm recording already. The voice also recorded. Okay, I'm recording. Okay, so I'm recording already. So everyone is here. All right, that's good. All right. So yeah, so PSPM 2022 and 2023. Yeah. So let's do the question together. So I think I will take the questions from here and paste it here. Yeah. Yeah. So that'll be good. Okay. So now, question one. Yeah. Question one. So figure 1 shows a student running 145 meter in a direction 20 degree east of north, and then 105 degree meter in direction 35 degrees south of east. So using components, determine the magnitude of resultant vector for the two displacement. Okay, so look at using component. Yeah, using components, find the resultant vector. So that means you need to resolve into components. Yeah, resolve into components and then find the resultant. Okay, so 20 degree east of north. Do you still remember about this? East of north and south of east. So still remember, if I'm recording, right? So east of north means this is north, east, southwest. So if east of north, that means from north go to east. East of north, that means from north go to east. East of north, that means from north go to east. So 20 degree. Okay, and then this one south of east. If so, be careful. Always remember from where lah. From north. This one from east. Okay. East of north means from north. South of east. That means south of east. That means from east. From east. Go to south. Go to south. Okay. From east go to south. South of east. 35. So it is correctly shown, right? Yeah, see that? 20 degree east of north, correct lah? Yeah, just shown by the diagram correctly. So this one also 35 degree south of east, correct also. Okay, so it's correctly shown there. Okay, now using components, find resultant vector. So how going to do? How are you going to do it? So that means components. All right, let's try. Hold on a second. Okay, let's draw the vector. Yeah. Oops. Yep. Yeah. So the first vector 145, that means is this one lah. 145 meter, right? So 20 degree. Okay. And then you must like this vector, you all have to make it start from origin. Remember I said make it start from origin if you want to find resultant vector. So 105 also put it at origin. So put it at origin over here. 105 meter. 35 degree. Okay. Yeah. So find resultant vector. Actually, resultant vector is this one lah. From here go to here. From here go to here. This is the resultant vector. This is the total displacement. Okay, because here we have S1, S2. So total is this one. Total. Okay, understand? To find the total, we must do this lah. Yeah, we must do this. Make it all start from origin. Okay, this is S1, this is S2. Okay, so resolve the vector, find components. So find components, this one also find components. This is X, this is Y. Okay, so what you're going to do is draw a table lah. Yeah, draw a table. Draw a table. No, draw a table. Draw a table. You need to have yeah. And okay, so okay. Oops. So I need to make it. Wait a second. Okay, there we go. So so here you have S1, S2, S total. Okay, so actually I don't need so many. Never mind. So this part no need lah. Yeah. Okay, so S1 is okay, remember going up positive, right positive, going down negative, going left negative. We must put all the sign. So for X component, S1 is 145 sine 20, yeah. And then for Y component, adjacent, so cos 20, yeah. 145 cos 20. Okay, degree, yeah. Make sure your make sure not in radian, in degree, yeah. Okay, so how about so cos 20. So how about this one, S2 is okay, S2 is X component is positive also, 105 cos 35. Okay, cos 35. And then for Y component is negative. Yeah, because going down, right? Going down is negative. Yeah, going down is negative. Negative 105 sine 35. Okay, going down negative 105 sine 35. Okay, so you get your total as x over here and total sy over here. Finally, what do you do? Find the Pythagoras theorem. Modulus, that means the magnitude. Just take the, sx square plus the sy square and square root. You get the resultant. And then also find tangent theta for the direction. Take the sy over sx. What is this? So sx, take the so, and then find the theta direction. Okay, theta direction. So answer, what's the answer? Let's check the answer. The final answer will be, okay, so yeah, it's a 155.46 meter. Yeah, 155.46 meter. So you get 155.46 meter. So direction not needed. Why? Okay, let me just copy the answer here first, because I need to refer this always. Copy the answer. Answer. Yeah, that's nice. Okay, so let me check. Wait, go back to the questions. So yeah, the question asks for magnitude. See that the questions? The question just asks for magnitude only. Magnitude, so you just give magnitude lah. Okay, if the question didn't ask for magnitude, he asked for resultant vector. Then you need to give both. You need to give magnitude and direction. Then only you get full marks. Understand, class? If the question asks to determine only the magnitude, you give only the magnitude. The answer only has magnitude. If the question asks determine the resultant vector, then you need to give both magnitude and direction. Then only get full marks. Okay? Understand? Okay. So just this one, just the magnitude. Yeah, just the magnitude. Okay, so that's for question 1. Now let's look at question 2. Yeah. Okay, everyone understand? Okay,
Understand, sir.
Okay. Can just give a thumbs up. So it's easier. Just a thumbs up. Okay. So yeah. Question 2. Let's look at question 2. Also we have this one. Okay. Oh. Okay. Wait. Okay, so let's try this one. The speed of train is reduced from 15 to 7 at distance 90 meter, approaching station A. Find the constant acceleration of the train. So this is kinematic only lah, kinematic formula, called kinematic questions. So this is U, this is V, this is displacement S. So find A. So V square equal to U square plus 2AS. Remember? Memorize the formula. Please memorize the formula. So 15 square plus 2AS. S is 90 meter. Okay, so what is the A? So let's find out lah. Later only we refer the answer, yeah. Distance traveled by the train before it stopped. So stop, that means final, yeah. Stop, that means V is 0. Distance it traveled before it stopped. Distance traveled before it stopped at station A. Distance is traveled by the train before it stops. That means start from U15 until it stop. Yeah, using the, okay, I need the answer A. Yeah, I need the A. The deceleration is negative 0.98. Negative 0.98. Deceleration, yeah, negative 0.98. So find the distance traveled. So find the distance traveled. So that this one also formula v square equal to u square plus 2as. So 15 square plus 2 negative 0.98 s again. So you can find the s already. Yeah, just now is negative 0.98 meter per second square. Okay, so find the distance travel. So distance travel is yeah, got two answer lah. Yeah, either is 25 or 115. Why got two answer, class? Because 115 start from the very beginning. 25 is after it travel 90 meter. So my one is 115. Okay, my one is total distance. 100 and this one should be 115. Okay, because I start from this one. I doesn't, if you start from 7, then the answer will be 20 meter. If you start from 15, then the answer will be 115. Okay, if you start from 7, then it's 20. Okay, right. Then while leaving the station A, the train accelerates uniformly with 2 meter per second square for 30 meters. Sketch a graph of acceleration against time during approaching and leaving. Okay, now this one is leaving. While leaving, it accelerate with 2. So this one, the ask for acceleration against time graph. Okay, acceleration against time graph. So how? I need to find time. Yeah, accelerate. Okay, I need to find time all the while. Yeah. So question, this question, question 3. Okay, so let's okay, so you have acceleration meter per second square and time. He asked for this graph. So he say approaching and leaving. When approaching, okay, this one is while approaching. See that? While approaching, it decelerate. 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 That means negative. This one negative 0.98. That means this one is approaching. Okay. And while leaving, it accelerate. Accelerate, and this is the value. 2 meter per second square. So that means the graph should be how? How is it? Cut into two parts lah. That means when approaching is decelerate. That means it's negative. Negative. That means it's negative 0.98 meter per second square. So it's this graph. And then while leaving is accelerate. This is just a dotted line. It's like this. Okay. So while leaving is 2. Okay. But I don't have the time, right? I need to find the time. When is the time where it what? Yeah, I have 0. Start from here, 0 second. So what is the time it reached the station A? And what is the time when reaching 30 meter away from station A? So how, class? Accelerate uniformly with 2 meter per second for 30 meter. So this 30 meter help you to find the time over here, and time over here is you need to find from if the speed becomes 0. Can you do it? All this while we didn't mention time. You need to find the time. Okay. So okay, start again. Start from u equal to 15 until v becomes 0. V becomes 0. That means wait, before it stops. Before it stops, while approaching at distance 90 meter, while approaching before it stops. Oh, so it stops at station A lah. It stops at station A, right? So that means while reaching the station A, he stops already. Yeah, that means this one v equal to 0 at station A. And then after station A, he start to accelerate. Okay. So find I got the A equal to negative 0.98. Find the time. Can you do it? Yes. Yeah. V equal to U plus AT. 0 equal to 15 plus negative 0.98. Yeah. T. So T equal to what? Calculator. Do you have calculator, class? Need to use my okay, 15 if divided by 8. So it's 15 point 31 15.31 second. Yeah, so I got it 15.31 second, class. And how about the next? What is the time when reaching 30 meter? 30 meter. That means over here, 30 meter. After accelerate. Okay, that means starting from, because you start moving from zero speed, right? Start and that and then you go to distance 30 meter. Acceleration is 2. Acceleration is 2. Okay. Start from zero speed. You go to 30 meter. Acceleration 2. So find the time. Find the time. S equal to ut plus half at square. 30. This one is 0. U equal to 0. Half A is acceleration is 2 t square. So cut. So t square is t is 30. Yeah. Okay, 5.48. 5.8 second. So 5.48 second. So here we write what time? Not 5.48. We must add with the previous time. Add with the previous time. So it's how much? 5.48 plus 15.31. So this one is 20.8. 20.79 actually, yeah. 20.79. Okay. So that's the time. Okay, class? Understand?
Okay, sir.
Yeah. So you need to label all the value, yeah? You need to label all the value. You cannot just draw the shape and no label. You must label all the value. So that means the time you need to find out. Okay. Normally it's like this, given marks. The shape correct, yeah. If you get the shape of graph correct, diagram 1 marks, and then label the value all correctly, another marks. Okay. And also we check the unit. You have unit or not? No unit, we minus marks. Okay. So 1 marks, yeah, 1 marks. So 1 mark, 2 marks. The value must get it correct. Okay. Now let's look at now look at this. Marble roll off the edge of cabinet at 2 meter high. If the marble landed 5 meter from the edge, calculate the initial velocity when it leaves the edge. Okay. So this is 2 meter high. So this one is SY, isn't it? Plus. And don't forget, you must put negative. Must put negative. Because what? Because going down. Going down. Yeah? Going down. Going down from initial position. So it's negative 2 meter. Landed 5 meter from the edge of the cabinet. That means the edge is over here. This is the edge. Okay. Or here also lah. Okay. So 5 meter. This is SX class, right? Not. So it fall So, so how do you do? This is a horizontal projectile. Question B. Horizontal projectile. So, horizontal projectile, x, y. So for first, ax, uh, ax is 0, right? Ay is negative g. Correct or not, class? This one you must know. Horizontal project. And then horizontal projectile is ux. Dia punya ux is 0. No, no, no. Ux ialah u. Uy 0. Tahu tak kelas? Ux itu ialah u sendiri. Uy ialah 0. Okay, Uy is 0. Uy lah kosong lah. Okay, Uy kosong. And then we have Sy. Sy ialah negative 2. Kan? Sebab dia ke bawah. Below the origin. Below the initial point. Sx, wait, Sy is I. So Sy di sini. Okay. And then we have Sx. Sx is 5 meter. Okay, class. So Sy negative 2. Sx ialah 5. Yeah. So next, what do you do? Find the initial velocity. So you need to find the time first, kan? Time. So you find the time. So like this one, the x component, you have only two known values, so you cannot find the third one. This one, y component, you have 3 known values: negative g, 0, negative 2. 3 known values, so you can find the time from here. You can find the time from here. Then you can use in the x component because they have the same time. They share the same time, isn't it? That's the trick. That's the way. So you find the time first from the y component. Okay. So start with y component. Sy equal to ut plus half a t squared. And these all are y component. Y. Okay. This one is 0. Yeah, because uy is 0. Horizontal projectile. No y component of velocity. Okay. And then half ay is negative g. So t, I don't know the t. Sy is negative 2 meter. Negative 2. So find the t, class. Find the t. Let's find the t. So 2 times 2 divided by 9.81. Okay, so the answer is 0. Wait. Let me check the answer again. 2 times 2 and divide by 9.81, and then set the answer 0.6. 639 second. Okay, once I got the time, find the S. Okay, so I can find Sx. Okay, I so use formula S equal to ut plus half a t square, but this time all x component. They are the same time, so the time this one can be used for x component already. So this is a 5 meter. So this ux is u, yeah, ux is u times 0.639 plus half acceleration. Oh, acceleration is 0, right? Because constant velocity. Remember that? Constant velocity. Constant velocity. Constant velocity. So find my u. Okay. So my u is equal to 5 divided by your answer. Yeah, 7.83 meter. Okay. Am I correct? Let's check the answer. Let's check the answer. Yeah, final answer. What's our question? None available. B is 7.8 meter per second. 7.8. Oh, see, meter per second. Unit salah. Macam mana? Nanti hilang markah. Don't. This is a common mistake. You and me also. So be careful with the unit. Meter per second. So 7.8. Yalah, 7.8 lah. Meter per second. Okay, class? 7.8 meter per second. Alright, so the next questions. Alright, 0. Okay. Now, the next questions. Question 3. Question 3. How are you, everyone? Okay. Okay, so this one. I do it one by one lah. Yeah, do it one by one lah. Part A and part B some more. Yeah. Okay. Figure 3.1 shows a graph of the horizontal net force exerted on 0.2 kilogram hockey ball varies with time. Calculate the magnitude. You want magnitude only. Impulse exerted on hockey ball by the hockey stick. So impulse. Remember how to find impulse, class? Impulse is the area under the graph. Impulse is the area under the graph. Remember you learned about several graph, or the area under the graph. Area under graphs. Let's do some revision. Area under graph of velocity time is displacement. Area of force time graph is impulse. J is impulse. Force displacement is work done. Force velocity is what? Power. Okay? Remember class? Force stress strain. Area under stress strain graph is what? Area under stress strain is what? Strain energy per unit volume. Kan? Soalan semalam kan kelas? Do you get it correct? Area under stress strain graph? Betul tak? Ada tak soalan ni?
Ada sih kemarin sih.
Area under stress strain graph is strain energy per unit volume. Betul kah Ayu? Kata betul kah?
Ngam. Betul sih.
Strain energy per unit volume. So, all this lah. Ya. Ada apa graph lagi? Tengok balik lah. Ya. Yang pressure volume. Yalah. Sekarang yang pressure volume graph yang itu thermodynamic. Dia work done juga. Class. Work done. Okay, so all this lah. So this impulse is force time graph. You see? So time. Kalau displacement ialah work done. Kalau time ialah impulse. Okay, so let's find out class. One. Okay, so impulse. So I need to impulse force. Find this is a trapezium. Do you know that? Trapezium, so write it down first. Area under the force time graph. Area under the force time graph. So trapezium is just or SI unit. Check the unit first. Newton, second, no problem. Okay. So 5 plus 1. 5 plus 1. Okay, this is 1. And then multiply by 20 Newton. 20. Okay, so what's the answer? Yeah, let's find out the answer. So 5 plus 1 is 6. 20 divided by 2 is 10. So 60 lah kan? 60. What's the unit class? Because J is actually FT. Kan? Impulse is at force time kan? So is Newton second lah. Unit. Newton second. Okay. Newton second. Okay. Now, what is the final velocity of the hockey ball if initially at rest? What's the final velocity initially at rest? So impulse is question 2. Impulse is actually change of momentum. Masih ingat tak? Impulse is actually change of momentum, which is mv minus mu. P final minus P initial. So P final is mv, P initial is mu. Impulse. This is impulse is change of momentum. So final velocity initially at rest. That means u equal to 0. Mass given 0.2 kilogram. So 60 equal to mass. Okay, this one is m v minus u lah. I factor out. So 0.2 factor final velocity. That means want to find v. Initial velocity 0. So what is your v, class? 60 divided by 0.2. So your v is 300. 300. 300 what? Meter per second. Okay? 300. So am I right, class? 60 Newton second, or yeah, and 300, right lah? Okay, done. Next, this one. These questions. So let's do these questions. Okay. Oops. Oh, oops. Happened. Okay. Okay, let's do this. Okay. Figure 3.2 shows an object of mass m1, 3 kilogram on a rough surface. Oh, rough surface. That means got friction. Rough. So it has friction, kinetic friction if you were moving. Connected to another object of 2 kilogram. Now, when a pulling force F is applied to the system or pull, both objects accelerated with the same acceleration. So the tension of the string is 25 Newton. Tension on the string. Okay, tension on the string is 25 Newton. Find the free body diagram for each object. Okay, so this is a good question actually. Free body diagram. So you need to draw the free body diagram, class. Acceleration by both objects. Okay, let's do it. Yeah. Okay, sketch free body diagram. So for each object, you see, each object, you need to draw the free body diagram for each object. Here, how many objects you have? 2 objects. So question 1, if you have 2 objects, you need to draw 2 free body diagram. Remember, class? Told you this one. 2 objects, you need to draw 2 free body diagram. So let's so this is mass 1 and this one is mass 2. So we start with mass 1. Start with mass 1. Okay, mass 1. So let's draw it out. Let's draw it out. How should I draw? Okay. Draw the axis. Okay, draw the axis for both. This one for mass 2. Okay, so we only have a point mass. Represent the object as a point mass, remember? Represent the object only as a point mass. Now, for mass 1, you have pulling force to the right. Pulling force to the right. You have tension to the left. To the right. No. Pulling force to the left. Pulling force to the left. Tension to the right. And this object actually moving pulling force. So it should move to the left, kan? It should move to the left, accelerate to the left, because it pull to the left. Now, tension. Let me see. 25 Newton. It didn't say this force is how big, Yeah, I didn't say, Okay, it didn't say the force how big, but just put acceleration to the left. So, friction to the right. Friction to the right. There's another friction. Because the surface is rough. Surface is rough. Friction to the right. Because acceleration to the left. So friction to the right. Okay, because the object is moving to the right. The object moving to the left. So friction to the right. And then we have the weight. Put it as W1 equal to 3G. And then we have normal. We have normal force for 1. Okay, that's the free body diagram. Finished. The tension here is 25 Newton. Newton, not meter. Okay, class. Another thing is this mass 2. Mass 2, yes, tension upward. Tension. Tension. It is 25 Newton. Okay, 25 Newton. Good. Mass going down. Weight 2 is 2 kilograms, so 2G. Okay, acceleration upward. Acceleration upward. Okay, done. Our free body diagram. Question 2. Find the acceleration experienced by both objects. Acceleration, find the A. How? If you want to do like mass 1, cannot, because you don't have this force, right? You tak tahu ini force apa. This pulling force you don't know. It's not given. This pulling force value. You also don't know the rough surface, what friction. You don't know what is the coefficient of friction. Yeah, not given the coefficient of friction. So you don't have these two value, force and friction. Okay, but if you look at mass 2, you have the tension, you have the weight. So of course this one can help you to find acceleration also. Understand? Can help you find acceleration. So let me check. T. So which one bigger? Tension is bigger, right? compared to the weight. Yeah. So T minus, yeah. For remember we say follow acceleration positive, opposite acceleration negative. Follow acceleration positive, opposite acceleration negative. Yeah, for second law, follow follow acceleration F positive. If opposite, kalau opposite direction of acceleration, F itu negatif. So ini kalau tension follow acceleration, so positif lah. Kalau W2 opposite acceleration, negatif. So kita boleh tulis T itu positif, W2 itu negatif. Because opposite. W2 itu negatif and equal to M2A for mass 2 only. So 25 Newton minus 9.81. G is 9.81 equal to this is mass 2 kilogram to A. So what is the A acceleration, class? 25 minus 2 multiply 9 point. Okay.
2.9.
Yeah.
2.69.
Yeah, 2.69. That's right. Meter per second square. Okay. Yeah. So what's the answer, class? Yeah, 2.69. Yeah. Okay, that's it. Yeah, very easy. Yeah, can find. So this acceleration is the same lah for both. Yeah, it's the same for both. This one you get 2.69. This one also 2.69 lah. Both of them must accelerate at the same rate lah. Both of them must accelerate at the same value. Okay, they both accelerate at the same value. Okay, 2.69, 2.69. So let's say the question asks you to find, let's say, friction or force. If given one of the value, friction, let's say given you friction, then you can use the acceleration value to find force. Okay. All right. So let's move on. Yeah. Yes. Very easy. Remember, free body diagram. Use point mass only. Yeah, point mass. Okay. Question 4. Okay. Okay, let's do the question 4. Now, all right, let's do this. Question 4. A giant ball with mass 60 kilogram accelerate from rest down a rough slope. The speed of giant ball at the bottom of the slope is 30. Work energy theorem. Find the frictional force experienced by the giant ball rolling down the slope. Okay, good. So the ball will reach at the bottom. Initially, U is 0 here. Finally, the speed is at the bottom is 30. Mass, this is the mass, 60 kilogram. Sorry. So rough. Okay, class. Frictional force. First of all, we must determine what are the forces involved. Because work energy theorem, apa itu work energy theorem, class? Work energy theorem. Work energy theorem means the net work done equal to change of kinetic energy. Right, not class? Change of kinetic energy. So we need to do this. So he asks you to find what's the frictional force. So the network done itself is change of kinetic energy. So the network done is got many work done, right? So the network done. So what are the forces involved? You must know how are the forces involved first. What are the forces involved? So draw the free body diagram first. So we have what are the forces involved? We have the weight mg. We have the friction. Okay. Friction. We have the that's friction. We have the normal force, class. Okay. So he didn't give you the slope. Oh, the angle. No need, because that's why I give you 300, 700. So he need you to find yourself. Use sine theta equal to 300 over 700. So find first your angle, class. Find your angle. This theta, important. So this theta will be equal to, this is the x-axis, this is the y-axis. Remember? Yeah. So this will be the theta also. Okay, can you see, class? My voice is quite sexy already. Sorry if you cannot. The voice is broken. Yeah. Boleh dengar kah? Boleh kan?
Boleh, sir.
Okay, so the
Boleh, sir.
theta is sine theta is 300 over 700. 300 over 700. Opposite over adjacent. Opposite over opposite over hypotenuse. Okay. Degree, not radian. So sine 300 divided by 700. So NP sine. So it is 25.38 degree. Okay. Then what else? Class. This 700 is also what? Actually, there is two ways to do this question. You know that, class? There is two ways of doing this question. Later, I will show you. Yeah, there is two ways of doing this question. But the question asks, there's two ways. Never mind. I show the first way. Yeah, the common way to do it. Okay, class. Remember, I told you what I told you about free body diagram. What did I told you about free body diagram? If chapter 3 you learn about forces, yeah, force, you must draw acceleration, kan? If you want to find the work done, chapter 4, you want to find work done, you must draw displacement, correct or not? Because I need to find the angle theta. This one you follow, yeah, got F positive, F negative, same direction as acceleration, positive, opposite acceleration, negative. If work done, we must compare with displacement to find the angle theta. And chapter 4 also has power. We need to draw velocity for that. Also to find theta. Remember that one? Let me redraw the diagram. Redraw the diagram so that it's better. Yeah, looks better. So okay, redraw the diagram like that. Okay. Okay. Okay, that is nice. Done. Axis just a gray one. Okay. So you have what? Just a point mass, yeah, free body diagram. You have the what? The mg, this one theta, have the friction, the frictional force. So not kinetic, actually it's static friction, but I don't want to mention here, just a friction. Actually it's static friction because ball is a ball, so it roll. If rolling is static friction, not kinetic friction. Do you remember that one? Actually it's static friction, not kinetic friction. Because it's a ball, it's rolling. If rolling is static friction. If it's a giant crate, if giant crate, not the ball, if giant crate is sliding down, that one, if sliding, not rolling, is sliding, that is kinetic friction. Okay, but I just put as friction lah. Okay, you need to draw the, as I said, this is to find work done. Work done, you need to draw displacement. You need to draw displacement, class. So displacement, yeah, this one, S. Okay, then only you can find work done, class. So work done by normal force, let's say, is normal force, displacement, cosine, what angle, class? Cos 90, right? Cos 90. Cos 90 equal to? Cos 90 equal to 0. Okay? If the force is 90 degree to the displacement, work done is 0. How about work done by gravity, which is work done by the weight? We just put mg as cosine. What's the angle, class? This is the angle. This is the angle. That means it's 90 minus the angle we got just now by using sine theta. So 90 minus what? 25.38. 25.38 degree. So what is it, class? So mass given 60 kilogram. 69.81. Displacement is 700. 700 cosine. So 90 minus 25.38. So it's 64.62. So answer hey, 9.81 multiply 700 cosine 64.62. Okay. So is what is the value? 1.766. 1.766 exponent how many? 3, 4, 5. 5 joule. Wow. Okay, how about the friction? Yeah, I don't know the friction, right? Work done by friction is friction as cosine. What's the angle? What's the angle, class? 180, isn't it? So it's -1 so is negative. Why is the displacement 700 lah, 700. So displacement is 700. So just put a friction there. Okay. So negative S is displacement. The S displacement 700. Friction. We don't know the friction, right? Not given the coefficient also, right? He asks you to find friction. So yeah, friction you need to find later. Okay, I got all the work done. So I can find my net work done. Correct or not, class? Okay. So wait first. Change of kinetic energy. Okay. So net work done is I can do it already. So net work done is work done by normal force plus work done by gravity plus all work done friction equal to the change of kinetic energy is final kinetic minus initial kinetic, which is half mv square minus half mu square, which is half m v square minus u square. So put in all the value here. Okay, put in all the value here. 0 plus what? 17.766 exponent 5 plus negative 700 friction. Negative 700 friction. So this one, half mass. Mass is what? 60 kilogram. 60. Work energy theorem means this formula lah. Okay. V square. V is 30. You see 30. Initial 0. So 30 square minus 0 square. See? So easy you can find. Find the answer, class. So finally you get the answer. For sure you get the answer. Want to work out? Can just work out. 30 square multiply 60 divided by 2 minus 1.766 colon 5 divided by 700. Okay, so the friction is 213.71 Newton. Am I right, class? Let's look at the answer. Friction is 213.71 Newton. Friction. It's not kinetic friction. Why I always write kinetic? It's static friction actually, but I just put as F friction. Okay. 213.71, correct? What question? 4A only, 4A. 4A. 213.69. Okay lah, almost. Kinetic. No lah, it's actually static. 213.71 Newton. Okay, got it. 213.71. Okay. Anyway, class, I want to show you that this is one way of doing. You can also do by work energy theorem, but friction. This work done by gravity actually is just mgh. Do you know that? Yeah, work done by gravity actually is just mgh. Actually is work done by gravity is actually mgh only. Mgh. Yeah. It's just a height using the height 300 meter. You still get the same answer, 1.766, and then finally you also get the same friction. Okay, let's try it. Yeah. Okay, what's the mass? 60. Gravity 9.81. What's the h? 300. Multiply and see. So 60 multiply 9.81. 300. See that, class? It's also 1.766. 1.766. See? Exponent 5. Sure. You still get the same answer, class. Yeah? Why like that, class? You must understand physics. You must understand. Then only you must understand what's happening. Okay? Work done by gravity actually is the potential energy. Potential energy change to kinetic energy. When talking about this one, like work done equal to change of kinetic energy. This one actually is like potential energy change to kinetic energy. But there are loss of energy due to friction. Work done by friction. Actually, it's as simple as work done is gravitational potential energy change to kinetic energy. So mgh is the same. Okay. You sure get back the same answer also. Okay, that's the answer for A. For B, I think we finish at for B, yeah. I know some of you, yeah, including me also, getting tired. Okay, I will continue question 5, 6. Wow, 6 is such a long question, huh? 7. I will continue the rest of the questions for another class, yeah, in the afternoon, F13. Yeah. I record lah, and then you can watch the recording, yeah, class. That's my planning lah, actually. Yeah. Um. Okay, so we done it for question A. For B, the last one. Whole family sick, actually. Yeah. Starting at Saturday, my wife sick. Saturday, Sunday sick. Then me started yesterday. Is it yesterday or the day before? I forget. Really. Well. And now my children. So for B, put it at the same page. Okay, so put it over here. So for B. Okay, so let's look at this. Nah, a 50-kilogram box is pushed 40 meter up a plane inclined at 30 degrees to the horizontal. We will force 400 Newton parallel to the place at constant speed 4 meter per second. Calculate the potential energy when at the top of the plane. Power used to move at the top. So you can see, class, I use already 1.5 hour just to finish not even 4 questions, that including my explanation. So 1.5 hour just finish 4. We have 8 questions, 8 questions to finish within 2.5 hours. So it's very time limited for PSPM. You have to do a lot of practice drilling to score in PSPM. Yeah, not enough time. All calculation question. So mass push. This is S. Incline. Horizontal force. This is pushing force. Parallel with constant speed. V. Constant speed is important. The word constant speed. Constant speed. Power, potential energy at the top. What are all these? Potential energy at the top. So how? 30, 40. Draw the diagram first. Yeah. Push, plane, incline. This is an inclined plane, class. They have a triangle here. No triangle. Into shape. Can I? Hey, I cannot rotate a class. Okay, wait. Let me try again. No need lah. Let me try again. I think. Okay. Okay, no need lah. Alright, this is the best way. Isn't it better? Okay, now push. So there is a box, push up, constant speed. Oh. Constant speed. That means yeah. Remember this is about power. Power. So we need speed. We need to draw speed, velocity to find power. Yeah. So 4 meters per second. The displacement is 40 meter. This is a 30-meter inclined plane. Push up with this plane is 30 degree to the horizontal, and with a force 400 Newton parallel to the plane. Force. This is a force F, 400 Newton. So it has 5 mg, which is 50 times g, and don't forget it has a normal force. Okay, and complete. We have the axis here. This is 30 degree. Yeah, 30 degree. This one also 30. Okay, that's good. Huh? Potential energy at the top of the plane. What's the potential energy at the top of the plane? How? What's the potential energy? You just use mgh lah, right? Mgh. So mg you got already, yeah. Mg 50g. You just need the h. So you have the s. You got the theta 30 degree. So 30 degree sine theta. Sine 30 degree equal to, this is the h. I need the h. H. Opposite over hypotenuse 40. Okay. So h equal to, let's find out, 40 times sine 30. Actually it's 20 lah, because sine 30 is half. Okay. Now mgh lah. Potential energy at the top is mgh. 50 times 9.81 h, 20 meter. So it's 50 times 9.81 times 20. So it's 9810 joule. That's the answer, guys. The top of the plane. Question 2. What's the power used to move it at the top? Power used. Constant speed, class. Power used to move it. So power used means power by the force lah. You want to find the power by the force. power by the force. So F dot V, power is F dot V. Kalau work done is F dot S. F dot S. Kalau power is F dot V, F dot velocity. Okay, remember? This revise back your chapter. Yeah. So that's why our free body diagram, you need to draw the velocity. Then only can get the angle theta. Like power force is F dot V. Formula is FV cos theta. Yeah. Kalau work done is Fs cos theta. Okay, so I can get 400. Velocity is 4 cosine. What's the theta, class? What's the angle between force F and V? Very easy. Parallel, right? Parallel means 0. 0. So cosine 0. Cosine 0 is 1. Correct or not? So 400 multiplied for 1000. So that is a power 1600 watt. This is a power, not work done. Work done will be more. Work done, this is power. That means work done per second. This is actually work done 600 joule per second, per 1 second. Yeah, you can write the unit as joule per second. If work done by force F is 400 multiply 40, then will be 16,000 joule. The work done should be 16,000 joule. 16,000 joule. If power is 1,600. If work done is 16,000, power is 1,600. 1,600 watt. Okay, power watt. That's all lah. Yeah. So is that correct, class? The answer. Let's check the answer. So this is a 4B. Yeah. 4B. Yeah, 9810 joule, 1600. 19810, 1600. 9810, 1600. Okay, that's correct. Okay, power watt. Okay, so yeah, I think I stop over here lah. Yeah. So wow, this one radius and force. Okay, do you want to go a bit further? Question 5, class? Do you want to go a bit further for question 5? So maybe the question 5, just a while. Okay, let's do question 5. Yeah. So then I can finish the rest of the question later. But I'm not sure I can finish all the other questions later. Yeah. Quite a lot, Maybe only one question I can finish. Maybe question 6 only. Okay, question 5. The last question lah. 5. How many questions? 5 marks. Wow. Okay. Centripetal force. Ferris wheel. Okay, so let's try the questions. 5. Question 5. A mass 50 kilogram. Velocity, constant velocity, V, radius, and centripetal force. To find the normal force also at the top and at the bottom. Constant speed. So this is easy question. That's why I can do it. So centripetal force is formula apa lah sudah? mv square over r. So 60 times v lah 16 square v square over r. R is 13. Okay, let's try. 60 times 16 divided by 13. So the answer is mv square over r. Radius of the loop. Yeah, it's correct lah. So 1181.54 Newton. 54 Newton. Okay, question B. What's the normal force at the top and at the bottom of the loop? Okay, draw out the diagram first, class. Draw out the diagram. I have a circle. Yeah, here. There is a circle here. Circle. Ferris wheel. At the top and at the bottom. At the top here. And at the bottom here. Okay. So you are at inside there. So at the top, bottom. Okay. So let's draw the forces involved. So you have this normal force, you have the weight, right? Here have the normal force, here also we have the weight. Okay, so center of circle is here, center. Okay, so centripetal acceleration towards the center, centripetal acceleration towards the center of circle, yeah, towards the center. So it asks you to find top and bottom, lower force. So how? So at the top, remember, follow as in chapter 3, forces. Follow acceleration, F near positive. Opposite acceleration, F near negative. Okay? Opposite acceleration, F near negative. So, this acceleration positive. So, macam mana? Ini F nya positif, ini F nya negatif. Okay. Sini pun F nya positif, ini negatif. Begitulah. Follow acceleration positif, opposite acceleration negatif. Okay, tulis. Total F equal to MA. Okay, at the top, W positif and negatif. So W tolak N. Okay, equal to MA. Ya, untuk ini adalah AC lah. wait, the question asks for normal force, right? Okay. So ini resultant force actually inilah FC, tahu tak? Dia adalah FC. The resultant force is actually the centripetal force, FC. You already got the FC just now. So use back. This one is actually MAC or FC. Okay. So bottom also the same. Ya, kalau bottom also the same. Just copy, paste. But for bottom, the positive is normal force. Terbalik lah. Normal force yang positif, negatif ialah yang work done. Not work done. The weight. Normal force, positive, weight, negative. Okay? Okay, so continue. So my weight, mass is 60 kilogram. Put it down. 60 times gravity 9.81. Okay, there we good. So minus normal equal to the centripetal force. The resultant force is centripetal force. 1181.54. 1181.54. 1181.54. So what's the normal force? So 1181.54 minus 60 times 9.81. Okay. Wait, let me see. This one, this one. So 60 multiply 9.81. 181.54. Okay, minus. Okay, the answer is normal force. Something wrong? Let me check the answer. So answer 1181 point. This one is correct. But for this one, normal force at 592. But why I get negative value? This one go to the other side. One go to the other side minus. Something wrong. The question got something wrong. I got negative value, which is cannot be negative. Actually, cannot be negative. But never mind. This one normal force equal to 1184. 1181.954 plus the weight. Weight is 60 times 9.81. 60 times 9.81. 60 times 9.81 plus 1181.54. So 1770.14 Newton. Is that correct? Yeah. Bottom is 1770.14. Correct. Yeah. 1770.14. Actually, class, this question got errors. The top one I got negative value. Actually, you say here positive, but actually it's negative. 594.94. Yeah, I get it negative value. Yeah, maybe he ignore the negative. Actually cannot ignore class. Okay, actually cannot ignore the negative. This is a wrong questions. It yeah, this is a wrong questions. Yeah, a wrong questions. Maybe this speed is too fast already. This speed is too fast. Too fast, that means it's floating already. You know that? That means it's not touching. If you got negative normal force, that means this person at some point, at some speed, he already becomes zero normal force. That means he's not touching the ground already. Yeah, at certain maximum speed. At certain maximum speed, is not in contact with the ground anymore. Yeah, so the normal force is zero at maximum speed. This one, this 16 is even more, even higher than the maximum speed. So uh you shouldn't get a negative value. Yeah, that means it shouldn't still touching the ground. No, yeah, actually it should be zero normal force. Yeah, this speed is too fast, and the person is flying inside the Ferris wheel already. This speed is too fast. Okay. So this question got error at over here. The value it give, this one got error, right? Okay, so that's all for right now lah. Yeah, 10:57. Okay, so the rest of the question, yeah, question 6 I will discuss with the other class. So later you check at my posted video lah at the YouTube, right? Okay, I will record the session with F13. Okay, thank you class. So, okay everyone?
Okay, sir.
Okay, sir.
Alright, so that's all lah. So sorry for uh taking so much time. Yeah. Okay, so I end the session. So I stop